The long profile of a river and its valley shows how the altitude of the river changes as it progresses from its source to sea level. The long profile of a river usually depicts it going from the upper level, where it is at a high altitude, to quickly falling in altitude by the middle course, where its profile starts to seem more gentle as it approaches to being horizontal in the lower course. Then, it is almost horizontal as the river feeds into the mouth at the sea or lake at the end. This occurs because the steeper gradients of the river tend to be eroded much quicker, which leads to the long profile becoming less steep unproportionally fast. The river cross profile of a river is the cross-section of what the river channel looks like. In the upper course of a river, the cross-section shows a steep V shape, with the water travelling at the very bottom, as the large particles of rock cannot as easily erode the sides, and instead over time, the water has naturally eroded a steep path. The cross profile then transforms into a U-shape by the middle course, as medium-sized particles erode the bottom of the bed more. By the end, at the lower course, the cross-section shows a relatively flat river, as the steep sides are largely more eroded than the bed over a longer distance. There are also some fluvial processes which you need to know, which can be split into erosion and transportation processes, along with why deposition occurs. Fluvial erosion processes include hydraulic action, abrasion, attrition, solution, vertical and lateral erosion. Hydraulic action is the erosion that occurs when the motion of water against a rock surface traps the air in the cracks or pores and forces the air pockets to experience a sudden increase in pressure, causing them to experience an intense mechanical weathering as the rock is dislodged. Abrasion occurs when particles carried by the river wear away its bed and bank. This can also include the sides of a river. This happens because particles like rocks will scrape surfaces and pick apart at them, eroding the surfaces over time. Attrition occurs when particles like rocks which are carried by the river smash together and break into smaller, smoother, and rounder particles. This can notably lead to extremely fine material in the water. Solution is the process of minerals dissolving in the river water and being carried as a chemical solution. The minerals, however, do need to be soluble and small enough for it to happen in the river temperature and speeds. Vertical erosion occurs as abrasion or hydraulic action act when there is a drop in height, since it results in the force from the water or particles dropping to wear away the surface it drops on. This is especially pronounced in the upper course due to the drop in the long profile of the river of large particles which then collide together. Lateral erosion occurs with solution and attrition, as the particles can spread out and wear out the sides of the river due to attrition, or the sides of the river can dissolve into the water due to solution. Fluvial transportation processes include traction, saltation, suspension, and solution. Traction occurs when large boulders and rocks are rolled along the riverbed. This usually happens up the long profile as materials have not broken down yet. Saltation is when small pebbles and stones are bounced along the riverbed. This tends to happen lower down the long profile, as the river materials have been more broken and worn down. Suspension occurs when fine, light material is carried along in the water. This material is often sand or small particles of soil. Solution can also act as a transportation process, alongside being an erosion process. Rivers deposit sediment mainly because they lose energy, which happens as a result of water flowing in a shallow area, or when the volume of water decreases. This can be highlighted with the formation of deltas, where at the mouth of the river spreads out and slows down, initiating the deposition of sediment, which leads to the river splitting into distributaries and decreasing the volume of the river even more, causing more deposition to occur. Ultimately, small separate mounds of sediment settle in front of the mouth of the river.